Hello and welcome back to Data Analysis and Visualization. I'm Jovita Christie, and in this video, I'm going to talk about the basics of GIS or GIS, which is used in making maps out of spatial data. So let's begin. What is GIS? Whether you choose to use a proprietary or open source application, the simplest way to make maps from spatial datasets is to use Geographic Information Systems software to help you do the job. So if you are given some spatial datasets, which means you have some coordinates and some information about those coordinates, and you want to plot that and make a visualization of that, then there are two kinds of softwares or applications available, open source and proprietary. But no matter which one you use, the technology that you would be using is geographic information systems. So if you know that, then you can do the job very well. Now, the proprietary GIS software available is ESRI ArcGIS for desktop. It's the most widely used map making application. But other than that, there's also open source QGIS, which you can find at www.qgis.org if you want to download it and use it for yourself. So you can go there, and it accomplishes the same task as the ArcGIS desktop version. So you can make maps with either of those versions. And there's another one which is called GRASS GIS, which is available at this link given right here, grass.osgo.org. And that's another open source alternative to ESRI products for which you have to pay. So in practice, all of these software applications are simply referred to as GIS or GIS. People use GIS for all sorts of purposes. Some simply want to make beautiful maps, while others could care less about aesthetics and are primarily interested in using GIS to help them make sense of significant patterns in their spatial data. So most of the people that use GIS use it because they want to create beautiful maps, maybe they want to show um, maybe they want to show a map of a particular country and color it differently based on things like population, based on things like average income of the people, so unemployment. So all these data, if you want to plot on a map, then that's where you will be using GIS. But there are people who just want to find some significant patterns in their spatial data. They also use GIS to create maps. To get a handle on some basic concepts, imagine that you have a data set that captures information on snow events. So there are snow events, which means there's a snowstorm or something of that sort. And when most people think of snow events, they may think of making a snowman or of scary avalanches or of snow skiing, right? When we think of snow events, that's what we think about. We think of making a snowman, we think of um, an avalanche, or we might think of snow skiing. But when a GIS person, that means a person who is into GIS, thinks of a snow event, he or she is more likely to think about snowfall rates, snow accumulation, or in what city it snowed the most. Okay, so a spatial data set about snow might provide just this kind of information. Okay, so you want to show on your data, you want to show on your map, what is the snowfall rate, what is the snow accumulation, and which city had in which city it snowed the most. Now, all this data, if you've ever watched a weather channel, that gives weather forecast or just news about the current weather, then you always see that just behind that news reporter, there's always this map that contains, all these this map, and it contains all the details. This is the temperature of this area, temperature of that area. So that's just what we want to create using GIS. Now check out this simple snow data set right here. Okay. So this contains 3 columns: ID, snow, and location. And it provides you very small amount of information. But you can use use the data in this table to make a simple map that shows what cities have snow and what cities don't have snow. So you can see that there are only 4 cities given here, and there's just a yes or no column where it shows you whether it snowed in that city or not. But you could create a map out of this and just show, maybe through color or something, maybe keep other cities green, and the cities where it's snowing, you could make them white, so just so they stand out. Now, although you can use this data to make a simple map, you need to have your location data in a numerical format if you want to go deeper into GIS analysis. Because just like you saw there are cities, just the names of the cities mentioned, but what you need are not names of the cities, but rather coordinates, because if you have coordinates, then you can plot them on the map. Okay, imagine that you go back to that table, the previous table, add 3 columns into that. The first column would contain latitudinal coordinates, the second column would contain longitudinal coordinates, and then there's another column um, for number of road accidents that occur at the locations where these coordinates intersect. Okay, so you're adding even the number of road accidents occurring at a particular intersect. Now, this is what the table looks like. Okay, so it contains a little bit more data than what we saw previously. Only 4 rows were there, but now we have 8 rows. Okay, 1 to 8. And the snow is given in millimeters. You can see here. Okay, 0 means no snow, obviously. Cities are given, their latitudes and longitudes are given. So now you have the coordinates and you can plot them. And it's also mentioned how many road accidents took place at exactly this latitude, longitude in the last 24 hours. So now this is our data. Now, when you have spatial coordinates, then which gives you the position and location, then you can use GIS to store, manipulate, and perform analysis on large volumes of data. And for the snow example, you could use GIS to calculate how much snow has fallen and accumulated in each city, or to determine the cities where it's particularly dangerous to drive during snow events. So because we want to correlate number of accidents happening with amount of snow, because if it snows more, then road accidents are more likely to happen. So we want to correlate the two, and that's why you could use GIS to calculate all these things. Where how much snow has accumulated, what is the relationship of that with the number of accidents happening in that area. Now let's try to understand what a spatial database is. The main purpose of a spatial database is to store, manage, and manipulate attribute, location, and geometric data for all records in a features database. So a spatial database is just like a normal database, but instead of storing all kinds of data, it stores specifically some attributes and locations and geometric data. Because it contains location, it is called a spatial database. And because it's a database, you have to be able to store, manage, and manipulate such data. So now what is an attribute? An attribute is a class of fact that describes a feature, which means if you consider our previous example, an attribute could be snow, amount of snow, it could be number of accidents, all these things together form attributes. What is location? So location describes what exactly is the latitude and longitude, what are the coordinates of that place on Earth, so that you can put it on a map. You can plot it on the map. And geometric data is either, it shows what kind of a geometric type the feature is. So if you're plotting a road, then you might want to use a line or something, okay? And if you're plotting, a city, and within the city you want to plot some areas, you might just use points, but you might use a polygon to show the city. So that is geometric data about your database. So for example, imagine that you want to make a map of all Dunkin' Donuts restaurants that also sell Baskin-Robbins ice cream. Okay, two things. Dunkin' Donuts restaurants that sell Baskin-Robbins ice cream. Okay, so the feature that you're trying to map here is Dunkin' Donuts restaurants, and the attribute here is Baskin-Robbins vendor, which would be a yes or no attribute, just like we saw in the first table, which had a snow attribute, which was yes or no type. The location fields tell you where these restaurants are located. Each store is represented by its own record in the database, and the geometric data tells you that these restaurants must be represented by points on the map, because it doesn't make sense to show restaurants using, polygons, because you would show the cities or something using polygons. Okay, you would not show restaurants using polygons, you'd rather use points. So I hope this is clear, what is an attribute, what is location, and what is geometric data. A spatial database is similar to a plain relational database, but in addition to storing data on qualitative and quantitative attributes, spatial databases store data about physical location and feature geometric type as well. So it's not just about qualitative, quantitative attributes, as you see in a relational database. Spatial databases also talk about physical location and the geometry type of your features. Every record in a spatial database is stored with numeric coordinates, which is the location. It represents where that record occurs on a map, because only if you have that, you can plot it on a map. And it also contains one of the three geometry types. These geometry types are point, line, and polygon, as we saw earlier, so that's quite clear. Now, whether you want to calculate the distance between two places on a map or determine the area of a particular piece of land, you can use spatial database querying to quickly and easily make automated spatial calculations on entire sets of records at one time. So this is the idea behind having a spatial data set, that just like you have a relational database and you can use SQL to, query such a database, you could also use some sort of a query language to ask questions to a spatial data set as well. And going one step further, you can use spatial databases to perform almost all the same types of calculations on and manipulations of attribute data that you can do in a plain relational database system. So whatever you can do in a relational database system, like, perform joins, perform subqueries, create views. So all these things you also want to be able to do on spatial databases. And most databases allow you to execute all these operations, which you can do in a relational system with a spatial system as well. So that was just a quick introduction to what spatial databases are and what GIS is. And in the next couple of videos, we are going to go through how these databases are created, what are the requirements, and even try to go through one of the tools, which is, the open source tool, which is QGIS, to create a spatial database and to plot it on a map. So I'll see you in the next video, and thank you for watching.